We have two functions and they have given us the sketch of the two functions. One is fx, it's a modulus function, and the other one is gx, what we call a rational function. So the first one, question number A, we have to find the value of fg1, which is a composite function. So let's do that. So fg1 means we have to put g1 inside of f. So let's find the value of g1. So g1 equals to, we have to plug it in over here, 1 plus 9 divided by 2 into 1 plus 3, that becomes 10 divided by 5, which is 2. So g1 is 2, therefore f of g1 means f of 2. So f of 2 is 2 modulus of 3 minus 2 plus 5. So we get 2 absolute value of 1 plus 5. We know absolute value of 1 is 1. It removes any negative sign and there is no negative sign over here. So 2 ones are 2 plus 5 is 7. Question number B. We have to find the range of gx. For range, we need to know what is the highest value and the lowest value. So let's check what the picture actually looks like. So if you want to know the highest point, then at the highest point, it is where the graph cuts the y-axis. So that means at x equals to 0, so it is going to be g of 0 means 0 plus 9 divided by 0 plus 3, which is going to be 9 divided by 3 is 3. So that's where it cuts the y-axis. So at the y-axis, it's 3. Now we need to know what's the lowest value. Well, it looks as if the lowest value is the x-axis or y equal to 0, but we cannot be certain. So let's see what the picture looks like. So this is a rational function and it will have asymptotes. So where will the asymptotes be? So let's check. One of the asymptote would be downstairs asymptote, that's the vertical asymptote. So if we do 2x plus 3 equals to 0, we will get x equals to minus 3 by 2, and that would be the vertical asymptote. We don't need the vertical asymptote for this sum. We need a horizontal asymptote. So for the horizontal asymptote, we need the coefficient of x. So that is the rule. So if you have y equals to ax plus b divided by cx plus d, then the asymptote of y is y equals to coefficient of x upstairs divided by coefficient of x downstairs, so y equals to a by c. That turns out to be, so that turns out to be 1 by 2. So the asymptote y equals to 1 by 2, which means it's something over here. So this is y equals to half. So that is the possible lowest possible value. Actually, it cannot be equal to half. It will be greater than that. So the lowest possible value is half and the highest is 3. That means the range is going to be between that. So gx is going to have a range of less than or equals to the maximum value 3 and greater than the asymptote. Asymptote cannot be called the minimum value. So we cannot write equal to sign. We have to write greater than that. Question number C, we have to find the inverse function. That means, first of all, we have to write y as gx because that's the first step. So gx is x plus 9 divided by 2x plus 3. So let y equals to 9x plus 9 divided by 2x plus 3. So let's find x from here. This is going to be y into 2x plus 3 equals to x plus 9. So 2xy plus 3y equals to x plus 9. So this is going to be, if you bring all the x on one side, 2xy minus x equals to 9 minus 3y. So if we take x common, it would be 2y minus 1 equals to 9 minus 3y. Therefore, x equals to 9 minus 3y divided by 2y minus 1, and that is the inverse function. So that means g inverse x is going to be, now let's convert the y into x, 9 minus 3x divided by 2x minus 1. Now we also have to find the domain of this inverse function. So remember, there are basically 4 situations for domain. The first situation is no restriction. So the second situation is we have a rational function, and this falls into the second category, the rational function, and the domain is going to be downstairs cannot be equal to 0. So that means 2x minus 1 equals to 0. That is not possible. So if we write 2x minus 1 is not equal to 0, that means x is basically not equals to half, and that is the domain. Now if you take a look, the first equation is y equals to 2, absolute value of 3 minus x plus 5. So let's see, what does this actually mean? What this picture, what this can look like? Now if you remember, when we do some sort of a transformation of absolute value, we can think of this like this. Suppose you have a line y equals to 3 minus x. So y equals to 3 minus x would be a graph like this. When x equals to 0, y equals to 3, and when y equals to 0, x equals to 3. So it will be something like this, a line like this. Now if you have a modulus on this, meaning the absolute value on this, the transformation would be, it would be broken down from below the x-axis and it will look like a V shape. So this is going to be 3 and this is going to be 3. Now what we have on this, we have 2 multiplied to this. So this is like C1 AFX. So if you multiply 2 to the fx, that means only the y coordinates are going to be multiplied with 2. So here the y coordinate is 3. So the y coordinate is now going to be 6. So the picture is going to be like this. The x coordinate is still 3. The y coordinate is now going to be 6 from the transformation AFX. Now what we have plus 5 to the entire transformation. So if you have 2 absolute value of 3 minus x, and now if you have plus 5, if the entire picture is going up 5 unit, and that is going to be, all the y coordinates are going to be added with 5. This is fx plus a. So this was, y coordinate was 0, 3 zeros. If you add up 5, it would be 3, 5. This was 6. If you add 5, it would be 11. So this is going to be the picture. So we can now write, so this particular point is 3, 5. And this particular point is 11. So now we have an idea what the picture looks like. Now they're saying fx equals to k. Now what basically means is, if this is equation 1 and y equals to k is equation 2, y equals to any constant is a horizontal line. So that means if you want to find the point of intersection between the two graphs, and there are two roots, meaning they're intersecting at 2 points. That's what it means. Graphically, it means it intersects at 2 points. Mathematically, it means then it will have 2 roots. So let's check where are the points that it does not intersect at 2 points. Well, first of all, if you think about this line, y equals to 5, then it intersects only at one point with the graph. And if you take this point, y equals to 11, well, it intersects at 2 points. Anything above, it intersects at only 1 point. So you cannot take above y equals to 11, you have to take below y equals to 11. And you cannot take y equals to 5, because at y equals to 5, it intersects only at 1 point. You have to take above y equals to 5. So we have this, the values of k can be, it has to be less than or equal to 11, because even if it is equal to 11, it intersects at 2 points. And it has to be greater than 5, because if it is equal to 5, it intersects at 1 point. It has to be greater than 5, and that is going to be the range of values of k.